converting between different types of concentration or different ways to express concentration is very important and often shows its head in AP Chemistry. Now we have three different types here. We've got molarity, molality, mole fraction, and mass percent. Mass percent is probably the only one that's a little new, but it's a percent, so it's part over whole times 100, so grams of the solute over total grams times 100. So these are the type of problems that you might end up with. In this one, we have an aqueous sulfuric acid solution containing 571.6 grams of sulfuric acid per liter of solution, and it has a density of 1.329 grams per centimeter cubed. That can be the same thing as grams per milliliter. They want us to calculate the molarity, molality, and mass percent and mole fraction of this. So first, let's start with molarity. So molarity is moles of solute over liters of solution. So first, let's figure out how many moles we have. So I have 571.6 grams of sulfuric acid. That's 98.09 grams in 1 mole. And so I get 5.827 moles of H2SO4. To get my molarity, it's moles over liters. So molarity is my 5.7827 moles, 5.827. And then they tell me it's per liter of solution. So I have that many moles in 1 liter. And so my molarity is 5.827 molar. Now, molality. A little bit different here. Moles of solute, so my molality is going to start with the moles, 827, and that's probably a pretty good step, first step for any type of problem that you have to do like this, over kilograms of solvent. Well, they don't tell me how much solvent. They do tell me that my solvent is water because it's aqueous, and so we have to figure that out. Here's where we're going to use our volume and this density. So if I take my volume, which is 1 liter, and I'm going to change that to 1,000 milliliters because I need milliliters for my density, 29 grams per milliliter, same thing as a centimeter cubed. Milliliters cancel out and I get 1,329 grams of solution. Okay, now that's not what I need here. I need kilograms of solvent. So I know how much solute I have. I have 571.6 grams of my solute. They tell me that in the problem. If I subtract those two, I end up with the amount of solvent I have, grams solvent. Now, for molality, I need kilograms of solvent. So I got to move the decimal over 3 places, 0.7574. kilograms. Moles of solute divided by kilograms of solvent, and you should end up with 7.693 molal. On to mole fraction. I'll just pick that up over here. Mole fraction is moles of solute, which we have, over total moles. So and we're going to do the mole fraction of H2SO4, usually specify which one you have. And so my moles, 0.827 moles, and that's going to be over my total moles, which is 5.827 plus the moles of my solvent. I have grams of solvent. I need moles of solvent. I know my solvent is water, so I can go from grams to moles. No problem. 18.02 grams in 1 mole. And that's going to give me, let's see, 42.03 moles. So we'll plug that in here. That's how many moles of solvent and solute that add up to equal the moles of the solution, or total moles. And I get a mole fraction of 0.1218. All right, now mass percent's the only one left. So I need my grams of solute, And so that's going to be 571.6 grams over the total grams in the solution. Move this back over here. Total grams. Well, I know, oh, over here, I did that calculation, and it was just the volume times the density to give me my mass of solution. So that's 1329 grams times 100. So my mass percent is 43%.